All right, next we now have Dr. Carmen Krapf presenting. She's the team leader of Mineral Systems and Resources, and she's working across a wide variety of projects to deliver high quality, competitive and industry advice across South Australia's mineral exploration sector, with a specific focus on delivering the Critical Minerals project for South Australia. With over 25 years experience in academia and government, Carmen is also passionate and engaging advocate for educating the next generation of geoscientists, which she's been very busy with already this week. Please join me in welcoming Carmen to the stage.
Thank you all for coming and welcoming you to our Discovery Day. I will talk today about two critical minerals that are not really mentioned widely in the whole critical mineral narrative we hear so often about. Just to recapture, a critical mineral is a metallic or non-metallic element that has two characteristics. It's first essential for our functioning, or the functioning of our new modern technologies, economy and national security, and also there is a risk to its supply chain. I know we always hear about rare earth and copper and cobalt and also the strategic metals, but as you might be aware, magnesium and manganese is also on the critical mineral list. So why we are looking today actually at magnesium and manganese. These are definitely not the minerals that are having the economic impact that copper and cobalt deposits would, for example, have in rare earth, but they are really, as I said, critical for our future life-sustaining activity on this planet. And as it turns out, well, manganese and magnesium, therefore, also on the critical mineral list. We recently undertook a study with an economic study with Adelaide University, the economic centre there, and they actually, while looking at all the critical minerals, flagged also magnesium and manganese as high potential for South Australia for the whole economy, and generally, the geological potential in South Australia is high and moderate for manganese. So the leading producers of manganese are currently China, and for magnesium China, and for manganese South Africa. The market size for those minerals are variable. So for manganese, we're talking about $6 billion. Sorry, it's a bit small on the front screen. Maybe you can increase the speaker's note a bit. And 40 billion for manganese. But the important thing is that actually the market for both of those are actually growing by about between 5 and 6%. And as I mentioned before, South Australia has really the potential, high potential for manganese, for magnesium, and moderate potential for manganese. So Geoscience Australia undertook an economic and geological potential assessment for manganese, for all the critical minerals, and came up with these nationwide critical mineral maps and their potential. And for manganese, there are actually, as you can see, not necessarily many spots in South Australia, whereas for magnesium, there's actually quite a lot. So South Australia has a really good standing in there. These assessments are really driven by understanding the mineral systems behind where we find manganese and magnesium. And for manganese, there are stratiform and sedimentary, supergene and hydrothermal, and magnesium mainly found in sedimentary carbonates and seawater and brines. However, me as the custodian of the South Australian databases, when we dive deeper into our databases, we actually see there's much more occurrences and deposits of manganese and magnesium, and that's why the Critical Mineral Project of South Australia undertook a detailed review and have been compiled by the lead authorship of Peter Keller. And this is what we're actually coming up with. That there's actually quite a lot of deposits that are spread widely across Australia for both commodities. But then if you actually look at the map, there's a bit of a pattern emerging. That actually in both cases, around the Adelaide Super Basin, these manganese and magnesium deposits and occurrences are really more common. So in the following, I really want to concentrate on the two, for manganese and magnesium, on the sedimentary systems where those form. And I want to talk you through, first of all, where they are and for what manganese and magnesium is useful, but also then what our geological endowment in those both commodities are. So let's start with manganese. Manganese is in use in alloys, in steel, aluminium, batteries, and fertilizer. And in South Australia, when we looked through our database, we have about nearly 200 occurrences. As I said, they're really concentrating in the Adelaide Superbasin, and therefore I'm actually would like to take you on a journey to find out how they form and also where we have actually our deposits. So the manganese, the sedimentary or stratiform or diagenetic are really the best understood manganese deposit style we have. They are formed in basinal settings, and that includes marginal basin settings, subduction-related zones, back arc, island arcs, and others, as you can see here on the top diagram. The primary source for manganese is most likely by the addition of manganese-bearing terrestrial sediment, undersea hydrothermal veins, and volcanic ash to ancient seawaters. And the best place to find these sedimentary manganese deposit is really at the basin margins, and this is where really the key sites are, where manganese oxide precipitation precipitates because of the rapid change in slope of the seafloor and greater likelihood for mixing between the deeper and the shallower water. And what area in South Australia would that really be a prime area to look for manganese is actually the Stuart Shelf. And with our recent work in the Zed copper space, we've done really quite deep dive into the Stuart Shelf and really understand the stratigraphy there quite now very well. So that also allows us actually to go back and see what other deposits or commodities than copper is there. And in this case, manganese has a really high potential on the Stuart Shelf itself because of the evolution of the shelf. So the Panati Lagoon the Panati Lagoon manganese field has been really the largest one we had here in South Australia. It was actively mined between 1950 and 1949. The manganese deposits are really here on the surface, so these are the dark areas along the lagoon. It's like a string of pearls. Nearly 35,000 tons of ore have been extracted from the surface with grades of about 40 to 55% manganese oxide. So where does this manganese come from? It's interpreted really as the weathering of the beta basalt being eroded into the actual shallow sea on this shallow carbonate platform, and where then the manganese-laden waters precipitated into the associated carbonates that were formed there at the same time. And then during the Cenozoic, with increased weathering and exposure, the carbonate rocks have been supergene enriched. Knowing now from our Zed copper study on the Stuart Shelf that we have much more extension of the Brighton limestone, so the carbonates, that there's actually much more greater potential to have actually manganese distributed around this area. This is a zoom in of how these deposits look. So they're surface near, supergene enriched, closely associated with the Brighton limestone in the lower part of the Tapley Hill Formation. And to give you also an example of that, there's still so much magnesium in the manganese in the system. This is a photo of the Cattle Grid pit. So we see the tailings in the background, and all the rocks that are on the surface are currently supergene enriched with manganese. So the formation actually is still going on. Let's jump to magnesium now. Magnesium, we know it's used in the steel industry, and also for health reasons. But I think the really emerging part for manganese is really in the water treatment. With increased use of aquaculture, we actually need more and more magnesium to actually treat that water that's used in fish farming and And therefore, it's really, really good to have a sustainable source, because we know actually humanity grows, there's more need for food and food security, so aqua farming becomes more and more important, and then suddenly more and more magnesium will be needed. And as it turns out, we actually have an active magnesium magnesite mine in South Australia. Just in case you haven't known it, the owner actually sits in the room, so Rick Horn. So again, I want to focus on these sedimentary carbonates where the magnesium forms. And as before, in the case of manganese, as a great example is actually in the Adelaide superbasin. So magnesium is in the Adelaide superbasin associated with the neoproterozoic scaliguli dolomite. It's part of the Burra group. And within the scaliguli dolomite, it's really concentrated in its upper part. The scaliguli dolomite has been deposited in fault-bounded subbasins during the renewed rifting and widening of the Adelaide Rift complex post-800 MA. And what we actually see is a succession of manganese layers intercalated with dolomite layers, and also the reworking of these magnesite layers into interclastic conglomerates within the formation. Manganese oxide contents vary between 38 to 45%, on average with 42, and the resource estimate by Keeling in 2019 is there's about 570 million tonnes sitting in the northern Flinders Ranges and the Wilurin Ranges. And the image on the right shows you the geological map and the extent of this massive resource. It actually has a strike length of about 120 kilometers. So now let me take you to South Australia's currently only magnesite mine. We were fortunate to be taken there as part of the EIGS field trip not long ago. Sitting in the northern Wilurin Ranges, the mine itself you can see in the background here, and this is the outcrop or the outline of the scaliguli dolomite, and from here on, it continues for about 120 kilometer strike length. So massive potential for extension of this mine with future increase for a demand in magnesium. This is an example of the Myrtle Spring mines. They have got these steeply dipping beds, and they're really kind of like easy to split off, and then will be actually reworked, and the magnesite will be concentrated. The other thing we see in the mine is that we actually often have structurally a repetition of magnesite beds. So we've got here a nice fold. These beds are about between like several tens to centimeters to about a meter thick, and there's multiple, like tens of those beds repeating and striking and cropping out over like about several hundred meters of strike. Yeah, and I want to finish off, because this is really also me as a sedimentologist, I have to talk about sedimentology, is really where do they actually form and how do they form? So the depositional environment for those deposits, the magnesite deposits, are really shallow marine to peritidal, and we have frequently subaerial exposure. The water depths are really low, so this is actually how the Stuart Shelf and the Adelaide Rift complex, in this case, sorry, the Adelaide Rift complex looked like around 800 million years ago, quite shallow. We have an extended carbonate margin, and then the magnesite, in many cases, originally deposits as these finely laminated micritic magnesite deposits. But because of the shallowness of the basin margin, we've got lots of reworking happening due to storms, and most of the magnesite deposits are actually concentrated in these interclastic beds. Indication that we actually had this dry, exposure of also at this margin is this really nice example in the center, where we have raindrop imprints on algal mats and also the desiccation mud cracks. In addition to that, we also have stromatolites quite frequently distributed throughout the succession, and they are also then reworked and incorporated into these intraplastic beds with the magnesite. So, I hope I got you now all excited about manganese and magnesium. In South Australia, we have great potential. Geologically, it's amazing commodities to work on. Who wouldn't want to work in the Flinders and around the Penati Lagoon? But of course, they're just a part of our potential for those commodities. I talked only today about the sedimentary the sedimentary mineral systems where they form, but we also have others, and we assess that as part of our critical mineral studies. If you want to actually follow up and find out more, there's these 2 publications that we have released on manganese and magnesite, and with this, I'll leave you for the next talk. Thank you.